Hello everyone, let's continue with the Sean Prasad list by solving missing number. So we are given an array nums that contains n distinct number from range 0 to n. Now I want to return the only number in the range that is missing from the array, and we can see from the input given that we have 302 and the only number that is missing is 2. Rather, we have 301 and the only number that is missing is 2. And the second example, we have 01 and the only number that is missing is 2 because the length of the array is 2. So we go from 0, 1, 2. Now, we're going to solve this in three different ways, going from the most intuitive to the least intuitive. And the most intuitive, the first one is just looping through the array. We loop through the array and we just return whatever number that is missing. Now this is intuitive in the sense that we know that the array is starting from 0 up to n, and when we also loop, our loop is starting from index 0 up to index n. So that's helpful. First we traverse the array and then we loop up to the length of the array. So the first number that we were given, the first array we're given is 301. The length of this array is 3. So we're going to loop from 0 up to the length plus 1. Why are we looping up to plus 1? Because we know that when you loop up to the length is not included. If we do not include plus 1, we would get 0, 1, 2. And that still does not give us the answer because we can see from both samples that we need the length, even if they are not included. 0, 1, 2 makes it the length. This is 3 and we need the length. We need the length of the array. So that won't work. So we have to increment our length plus 1 and then we go up to 0, 1, 2 and 3. It won't get to 4. Now what we can do is we just put a conditional after traversing. We put a conditional to check if the number does not exist. This question is so easy because the index matches the number. So if the index does not exist, automatically the number does not exist, and then we just return that number. Now this is the first one. This is the first way that we would be solving this problem. The second intuitive way is to sort the array, and we'll be using a cyclic sort for this. So we have an array of 3, 0, 1. So we would sort the array in place using a cyclic sort, whereby we compare each value. We compare this with this. Do they match? Well, no, they don't. Or are they at their appropriate index? Again, this question is simple in the fact that the index matches the number. So we know that 0 should be here, 1 should be here. Well, there should be 2 here and there should be a 3. So we'll use a cyclic sort to check, does the index match the number at the position? If it doesn't, we swap with the next one. Then we compare the next one. Does it match with the appropriate index? Then we swap. So we do the cyclic sort first, where we sort this array to give us 0, 1, 3. After sorting, then again we are going to traverse. We're going to traverse the array, and again, just like what we started with, the first example, we're bringing it back into this. First, we are sorting the array, then we are traversing to see if what number is missing at what index, and we would say that 2 is missing, similar to what we did. Now this would be a good time to try out the first method. That seems clear enough. And if you can give this a try, also do I think this one might be a bit tricky, though it's still intuitive, because you have to sort and then you have to traverse, just like what you did for the first one. The only difference is that in this instance we are sorting first. Now the time complexity for the first one we didn't discuss. It is going to be O of n, since we are looping just once, right? We are looping just once for the first method. We are looping just once, so it's going to be O of n. We don't use an extra space, so that's also going to be O of 1. Now for this sort method, our time complexity is also going to be O of n. The first thing is that we are sorting in place. We are looping through the array in place, and this is O of n operation since we are sorting in place. Then we are looping through the array again to search for a missing number. Now this is not done. This is not a nested loop. It is done outside of the sort loop. So after sorting, then we are traversing after we had sort. So that's O of n plus O of n operation. They are run consecutively after one another. We have to wait for one process before we do the other. It's not that one process is depending on the other, in which case it will be nested. So this is why we have this, and this is going to be O of 2n square. And we know that when we have O of 2n square, this one doesn't matter. And we don't use any extra space. You will see in the code we don't use any extra space. So that's also O of 1 operation. Now let's move on to the third and final step, which is the math. We'll be solving this problem through math. Now this is not very intuitive. I definitely didn't think of this at first. Now what are we going to do? Again, we're going to be summing up all the values in the array. So again, let's bring up our array. We have 3, we have 0, we have 1. We're going to traverse this array. We're going to sum it up to equal 4. Now there's a nice math trick whereby we get the length of the array. Let's assume the length of the array is n. We multiply it, then we increment it and get the floor value, then we deduct the total from it. This formula is going to give us the missing number in the array. So this is the 3 solutions that we'll be coding up now. Again, if you haven't tried it, if you have understood it, now is a good time to code it up. Even if you haven't understand it, now is also a good time to go back on the video, try to understand it before looking at the code. It's always helpful to understand what you're about to write. Now let's jump right into it. So this is going to be the first one where we're traversing through the list. So for I in range, length of nums plus 1, don't forget the plus 1. If I not in nums, if I does not exist in the nums, then we want to return I. We're not giving a case where there would not be any missing value. Otherwise, we could just return -1. But we're not told that there will be a case where there is no missing value. So we can just run this. Now, why we don't need the nums, we're using the index, is because the index matches the values. We know that there's 0 up to n. So, and when we loop, we're looping over the index. So it really doesn't matter. We know that this is definitely going to work. So we are cool with that. Cool. Now this is the intuitive approach. Now let's work with our cyclic sort method. I'm just going to reset this to default. So we have I equals to 0. This is the first index that we're starting from while reversing, not really reversing, while sorting in place. So while I is in bounds, this is the number that we'll be swapping with, the number at that index. Now, if Since the index and the number is in bound, we can just check if this is in bound, and nums I is not equal to I. Again, like we said, 301. We know that this problem is always going to match its index. So we can do this, that if the number does not match the index at which it is, then we want to swap it. And in Python, you can do it like this. We are swapping in place. Otherwise, we want to increment our I. If our I is at the correct index, then want to move on to the next index to just check, because it is also possible that we have, like we can see in our second example, something like this, in which case they are in place and we don't need to do anything. Now we believe that our array is sorted. Okay, so dents. So for we're checking the index in this case. So for the index in the range of the array length, if the index at any point does not match the value, then we found our culprit and we want to return the index. So for instance, once this is sorted 301, once it's sorted to 013, we know that, okay, we kind of go through the index. 0 matches the number at this, 1 matches the number at this, 2 does not match the number at this, it doesn't. So we want to return this index. That means 2 is missing from here. Then in the instance that we have something like this 01 and no number is missing, then we know that the last number, the length of the nums is missing. So we're just going to return that instead. We're going to return the length of the nums. So I like to just run all of the example. Oh, this is wrong. We just need 1 not equal to sign, not 2. So let's try that again and not have stupid syntax errors, basic errors, syntax errors. Okay, cool. That runs too. We're just going to reset this and continue. So we can say that, like we said, we're going to be having a total because we want to sum the values. Our total is equals to num. And let's just have a variable that holds the length of the nums. So for I in range length of nums, again, we're going to be having a total. So this, for every item in the index, we are basically just running a total on the sum. And after we've gotten the total, we can just return the length, the formula that I gave earlier, n plus 1, once you get the floor value, because it is possible that it's not rounded up. Then want to deduct the total, and this is just going to give us the missing value in the index. This is a math trick. Now we can submit this, and we can see that this runs. A good trick, like we discussed, is to go through, you can click on your accepted, and you look at, okay, we are quite here, that's nice. You can also look at other responses that are better than yours, and even those that are not better than yours, just to, now this is a really cool trick. So yeah, you want to just have a look at what people have done and learn from them. This is a cyclic sort, similar to what we did. This is a cyclic sort, and yeah, this is really cool. And we can also check this space complexity, what others have done, and be able to learn from them. Yeah, this uses nums.sort, but this is going to have a log n log n operation, because sort has n log n operation. Another good trick is also to, you can check the related topics to kind of like see all of the methods and techniques that we can use when solving this problem. All right, I hope you enjoyed this video and it was helpful. I'll see you on the next video. Please support this channel, subscribe, like, comment, and share. Thank you. Bye.